All right, so good morning. This question is again a very good question on the topic of centripetal force. So let's read the question first. There is a mass attached with a string, but the motion is horizontal circle, not a vertical circle, right? Question is, what is the maximum angular velocity which is permissible given the fact that the tension in the string should not exceed a certain value? Okay. Now, if you read the question correctly, the mass is given to be zero point 0.5 kgs, right? So this is zero point 0.5 kgs. Okay. The okay, the tension which the tension possible in the string is given to be 324 newtons, right? So this is 324 newtons. It's a horizontal circular motion, right? Okay. Let me draw the diagram also. So the diagram looks like this. Remember, it's not a vertical circle. That is, we're not rotating it like in vertical plane, but horizontal plane on the maybe ground. Now the question is, what is the maximum possible value of angular velocity of the, and the length of the string is given to be 0.5 meters. So the L is also known to be 0.5 meters. Okay. Now we have to calculate how much, what is a permissible, right? So what is the reason for this body to be in circle? The tension which is in the string is providing the necessary centripetal force. Centripetal force is not a real force, but somebody else has to provide it. In certain questions, friction provides the centripetal force. In this case, tension in the string is providing the centripetal force. So tension will provide the necessary force, and then 324 is your limitation, 0.5 omega square, and our radius is 0.5 square. This is going to be the radius of the revolution divided by 0.5, right? So 1.5 cancels with this, right? So what you're left with is omega square is equal to 324 upon 0.5 square. So omega is equal to 18 upon 0.5 is equal to 36 radians per second. So this is the maximum possible value of the angular velocity with which you can do the horizontal motion. If you exceed this, because your hand decides what is the velocity going to be. If you start rotating it more faster in the horizontal circle, then the string is likely to break because the threshold of 324 newtons will be crossed. I think it's a good problem. It's not a vertical circle, just remember, where in the vertical circle scenarios, okay, the diagram is the tension throughout the motion keeps on changing at different points, right? So the tension here is different, the tension here is different, the tension here is different, right? So this is not a, so what you need to read when question is it a horizontal circular motion in horizontal plane or a vertical circle in the vertical plane? So I hope you like this question. It was a straightforward, short and sweet question, but good to understand the distinction between vertical and horizontal circle. Please go to my playlist of circular motion and rotational kinematics. You will see some fantastic questions. Your stress level will go down because of the clarity which this channel provides you. It is a clarity which will reduce your stress, not solutions. I can write something, but I won't give you any reason why I'm doing that, right? Which is what happens on the dumb websites. Nobody explains you what exactly is happening, why you're doing this, why you're doing this. Nothing is explained. This is the only channel which will explain everything to you. So don't forget to subscribe to this channel. Thank you very much and wait for my next video.